section we're going to be talking about today is going to be section 3.2. In section 3.1, we found the point of intersection using the graphing method. In section 3.2, we're going to find the point of intersection by doing elimination and substitution. So, elimination. It's a method used to find the intersection point of two lines in the same coordinate plane. It's also known as combination. Okay? The equations must be lined up. X's over x's plus y's over y's, equals over equals, constant over constant. If they are not lined up like this, you will not be able to perform the operation correctly. A and B are your coefficients and C is a constant. So, your goal is to examine the coefficients of the variables and then determine which is easier to eliminate by finding the least common multiple. Now folks, whenever I say least common multiple, a least common multiple cannot be smaller than the largest number. You do the multiplication tables. We talked about this previously whenever we did fractions and reducing of fractions. Okay? Coefficients must be opposite of each other so that whenever you add them, they cancel out. So here are the steps. So you are going to do these steps by yourself as we do the homework problems. You're going to calculate the LCM of the x's. You're going to calculate the LCM of the y's. Then you're going to go ahead and determine which variable is easier by eliminating the LCM. Look at the current signs. One might be easier than the other one. Then you're going to multiply the equation by the value needed to get you plus or minus the LCM. Then you're going to add straight down, and then one of them is going to cancel out, and you're just going to have one letter left. You're going to solve for that variable, and then you're going to plug and chug that value you got into one of the original equations. Okay? And then this is your POI. So let's go ahead and do this. Step one, are my x's over my x's, my y's over my y's, my equals over my equals, and then my number over my number? The answer to that is yes. So I need to go ahead and look at my x's. What is the first multiplication table in common for the x's? If you said plus or minus 6, you would be right. How about of your y's? The LCM of your y's is going to be plus or minus 12. Which one's smaller, 6 or 12? 6 is smaller, so that means I plan to eliminate x's. So that means I need to have positive 6x in one of the equations and a negative 6x in the other equation. We are going to multiply by a value to obtain positive 6x and to obtain negative 6x. So if I do that, what do I multiply 3 by to get a positive 6x? Well, the answer to that is 2. So I'm going to take the top equation and multiply it by 2. So that's going to give me a 6x plus 8y is equal to a 2. So I've turned the top equation x to have a 6x. Now I need the bottom equations x to turn into a negative 6x. So what am I going to multiply 2 by to obtain a negative 6? The answer to that is negative 3. So this is negative 6x minus 9y is equal to negative 21. So now what I have done is I have two new equations that are exactly the same as the above ones, but I multiplied them by a value so that I can eliminate them. So now I'm going to add straight down, and the x's go away, and I'm left with negative y is equal to negative 19. Divide by negative 1, and I have y is equal to positive 19. Meaning my point of intersection where they cross out in space is going to have a y coordinate of 19. So how do I find the x coordinate? I simply am going to take one of the original equations and I'm going to plug and chug. 19 and 4y. So that's going to be 3x plus, that's a 6, 76. I'm going to subtract 76. So I have 3x is equal to negative 75. Divide by 3, and I get x is equal to negative 25. What this means is these two lines are going to cross out in space at the ordered pair negative 25, comma 19. Now, if I wanted to check that I was right, I could very easily come over to Desmos and I can type in those exact original problems. That original problem was 3x plus 4y is equal to 1. 3x plus 4y equals 1. And the other one was 2x plus 3y is equal to 7. And hit enter. And I said it's going to be at negative 25. So if I hit one of these and I click on that, am I right? I sure am. So I know I did it right and I don't have to worry. Okay? So let's go back here and let's do this again. So I'm not going to check them anymore. You can check them, but that is just one way that you can. Okay? So I'm going to say, are my x's lined up? Yes, they are. Are my y's lined up? And are my numbers? Sure. So I'm going to go ahead and look at my x's. 2 and 6. What is my least common multiple? Well, that's going to be plus or minus 6. What about of my y's? That's going to be 3 and 9. So that's going to give me plus or minus 9. Which one's smaller? Well, in my opinion, it's easier to work with the x's to get rid of. I already have a 6. So I need to change this top one to the 2x needs to turn into a negative 6x. So I'm going to multiply that by a negative 3. So negative 6x plus 9y is equal to negative 18. Drop down the bottom equation because we are not doing anything to it. And simply add straight down. And I get 0 is equal to negative 9. When does 0 equal negative 9? Sometimes, always, or never. It never equals negative 9. This is never true. It is a false statement, which means when do these two lines ever cross out in space? They don't, and they are parallel lines. Okay, does that make sense? Next, same exact thing. Okay, what do we not like about this problem? Well, I'm going to say what you don't like is immediately your eye was drawn to those ugly fractions there, and you're like, I don't like that problem. Well, you don't have to fret, because what we're going to do is simply multiply the whole thing by the LCD, which is 3. So I'm going to drop down my top equation because I'm not doing anything to that. And I'm going to simply distribute the 3 to give me this equation, which means I no longer have to look at the top two equations. These two equations right here become my new original equations, okay? So now I'm going to come right here. I'm going to say, okay, what is my least common multiple of my x's? Well, that's 5 and 10, so that's going to be plus or minus 10. How about of my y's? That's 7 and 14, so that's going to be plus or minus 14. Obviously, x's are smaller. I already have a 10 here, so I leave it. So that means this top one, the 5x, has to be the opposite of a 10x to give me the negative 10x, so I have to multiply that by a negative 2. So negative 10x plus 14y is equal to negative 8. Drop down the second equation and keep it unchanged. And add straight down. I get 0 is equal to 0. Is that sometimes, always, or never true? That is always true. You know what that means? They're exactly the same line, and every point on that line is going to be a point of intersection. And you can use either equation that you want. Okay? So I've kind of talked about elimination many times, and we've done that already. So let's go ahead and talk about the next method, which is substitution. Anybody who watches a sporting event understands the concept of subbing. One player goes out and another player goes in for them. That's what substitution is in the algebraic world as well, in the world as well. Substitution method is whenever you take and you use to find the intersection point of two lines, and it is best used when the coefficient is 1. You are going to solve for one variable and plug an expression in elsewhere in a different equation for that letter. So how do we do this? Step 1. Choose one equation with a coefficient of 1. Guys, I cannot express enough how important it is that you choose equations with coefficients of 1. If you don't choose equations with coefficients of 1, what happens is you are going to have nasty fractions. And fractions are not your friend, generally speaking. So you want to stay away from them as much as you possibly can, okay? Then you're going to solve that equation for the variable you chose. You're going to plug that expression is super important here, into the other equation for that variable. You're going to solve for the new variable, and you're going to plug that value into the expression, and that's going to be your POI. Meaning, here we go. 4x plus y is equal to 5, and x minus 2y is equal to 8. I want you to pick either equation 1 or equation 2. And I want you to choose the equation that has a coefficient of 1. Well, look. This is 1y, and this is 1x. Doesn't matter which one you use. 90% of the time, my students are going to say, I want to choose equation 1, and I want to solve this for y. I always want you to be like Hansel and Gretel and leave yourself little breadcrumbs. Explain to yourself what you're doing on paper so that when you walk away or you get a phone call or something, you can come back to it and not miss a beat and know exactly what you were doing. So I'm taking equation 1 and I'm going to solve it for y. So that's 4x plus y is equal to 5. That means I'm going to subtract 4x from both sides, and y is equal to negative 4x plus 5. Box that expression in. Because now I'm going to use equation 2. And I'm going to plug and chug. PNC means plug and chug. So that's x minus 2y is equal to 8. Every place you see a y, you are going to plug in the negative 4x plus 5. So x minus 2 times negative 4x plus 5 is equal to 8. And you're going to solve. So this gives you an x plus an 8x minus a 10 is equal to 8. 9x minus a 10 is equal to 8. Add 10. 9x is equal to 18. Divide by 9, x is equal to 2. Take that 2 and go right into the box that is already solved for y. And plug and chug. Negative 4 times 2 plus 5, negative 8 plus 5 gives you negative 3. So that means my POI is the point 2, negative 3. And you're done. That is substitution. Now, substitution is not as organized down. It's kind of all over the place. So a lot of kids prefer elimination because you can do elimination anytime you want, and you don't have to look for coefficients of 1, but both methods work fine, okay? So let's go ahead and do this one. Okay, well, what are we going to do? I look at this and I say there's no coefficient of 1. So if there's no coefficient of 1, it's which evil did you rather choose? So I'm going to still take equation 1, and I'm going to solve this for y. Okay, so that's 3x minus 2y is equal to 16. Negative 2y is equal to negative 3x plus 16. Y is equal to 3 over 2x minus 8. Now, I have to use the other equation. So I'm going to take equation 2 and I'm going to plug and chug. Equation 2 is 4x minus 3y is equal to 23. I'm going to plug in every place I see a y, the expression 3 over 2x minus 8. Positive 3 over 2. Minus 8 equals 23. Okay, so I'm going to distribute 4x minus 9 over 2x plus 24 is equal to 23. Now I'm going to subtract 24. So 4x minus 9 over 2x is equal to negative 1. Then I'm going to cheat. I'm going to multiply everything by 2. 8x minus 9x equals negative 2. So negative x is equal to negative 2. So x is equal to 2. I go into the box. Y is equal to 3 over 2 times 2 minus 8. 2's cancel out. 3 minus 8. Y is equal to negative 5. This means my POI is 2, negative 5. Which I'm going to tell you straight up, This problem would have been so much easier doing by elimination. But I wanted to show you that it's possible to do it by substitution. It's just uglier. Okay? Tonight's homework is going to be 3-2, worksheet 1, solving systems of equations.